Hello everybody. So, for today's video we're going to be talking about curl and divergence. One turns into a vector field and one creates a scalar field. But they're both acting upon vector fields. So keep that in mind. First aspect of these two is the curl. So if you have your vector field in 3 dimensions and the partial derivatives for all 3 parts exist. So that means the partial p with x, partial p with y, partial p with z. All 3 have to exist. And the curl of f is the vector field on R3. Again, that just means in 3 dimensions, defined by this equation. So you notice for the x term, well, R isn't dealing with the x to start with, Q is not dealing with x, so they're not having any partials with respect to x. So it's the same type of situation we've seen before, where when we're dealing with the x term, the functions and the partials do not deal with the x terms. Furthermore, they are reversed. So R deals with z, but it's the partial with respect to y. Then we have similar for j and k. So keep in mind the order can get a little confusing with this. So keep that straight. Make sure you have it written down somewhere. It'll help you out. And this one ends up as a vector field again. So it takes a vector field and creates another vector field. Let's go and take a look at the divergence. So divergence is a little different. So it starts with a vector field, but now we only require the partials corresponding to the same value, essentially. So P is with the x values, so the partial with respect to x has to exist. Q with y has to exist, and R with z has to exist. The other ones, we don't care if they exist or not. So this one's slightly looser. Now, when you actually calculate the divergence, you end up going to get a function of 3 variables, not a vector field. And for this one, you are just adding up the partials with each thing individually. So those are the basics of what a curl and the divergence are. These things have a lot of usefulness in magnetism, electricity. Those formulas show up a lot. So we'll talk a lot more in detail about aspects of these that are kind of nice. So I'll see you in class.